All right, this is the second video, and in this video, I'm going to primarily focus on actual models, experiments, showcases, whatever you want to talk about, the things that come with the MLTK, with Python, etc. And we're going to really focus on that. I do highly encourage you to watch my first video, look down below if you're not sure what I'm referring to, where I discuss a lot of the quick wins and a lot of the value you can use, get all this stuff with just native Splunk instead of adding all this stuff into it. But we're going to focus here primarily on the models and the modeling language that machine learning gives you. So we're going to go through here again. Remember, this is a little process. We need to collect data, clean, transform, explore, visualize, model, evaluate, and then deploy. And I'm going to more or less show you that process. I've got a little app that I built that helps kind of, for me, put a little of those key points there. But anyway, so the first thing we need to do is we need to remember step one, which I didn't, step zero here. What is my story? So let's jump to my Splunk instance and let's go talk about a story I've come up with. The story I want to come up with, and we'll jump over, we'll keep this search here, but if I come back here and I go, let's just grab this query, copy it so I don't have to write it again. I come to Lane Models, Inventory Exploratory Data. That is what I'm calling this. And the principle here, I've written it all out, so kind of got a nice little documentation of what I've done. And what I did is we'd like to be able to determine what kind of devices are being observed by looking at the internet traffic logs. We'd like to identify business systems, OT devices, network scanners, and admin workstations. Basically, I could have made this a little more detailed, but the concept was I want to be able to grab internet traffic logs and be able to classify what these systems are. Think of the way that, for example, Nmap works. Nmap will ping an entire network, ping a bunch of ports, and based off what responds back, it'll give you, it will try to derive the inventory. That is basically an AI. Believe it or not, Nmap's been doing that long before AI was a cool buzzword. Nmap was trying to identify what the systems were based off key indicators in its queries and its responses. So the question comes back, do we have the data? Can we collect this data? And what kind of data do we have? And from that, are we able, as experts, to be able to derive any form of inventory from that? And that's almost going to come back to this, will this be a supervised or unsupervised model? Um, and I'll come back to this in a minute, but we're going to start with, do I have the data? And so if I come in here and I write a query, we're just going to erase this. And I'm going to come look at my bots v3 data, source types. I'm going to go everything related to stream. Stream is Splunk's built-in networking tool. There are other places you might have DNS, you might have domain, uh, you might have firewalls, you might have proxy traffic, there might be a bunch of different things that you do to collect network logs. I'm going to grab something anyone can use, so I'm using the bots v3 set. If you go Google Splunk bots of the SOC v3 bots v3, you'll actually find a GitLab, GitHub. You can go download it, and you'll have the exact same data. I just set it all time because it's historical. There's only data back in 2018 or 17. But when I look at these, I've got ARP, DHCP, DNS, HTTP, IP, SQL, SMB, SMTP, TCP. All right, let's just start with something really simple. I'm going to come back here and I'm going to make a query, duplicate this tab, and I've got stream MySQL. So let's go look at those logs. Source type equals, get rid of the metadata command, indent type, and let's go grab the first head 100 logs. If we look at these, we can see a query. Set names UTF-8, set query, select title template from. This one didn't have a query. I'm actually going to tell you that I'm pretty confident with this protocol, particularly when you see what it's doing, but I'm going to use that, come back to this in a second. Here, this is definitely parsed. If this was a false log, does that make sense? You gotta be careful. Sometimes you're gonna use parsers, and I'm gonna particularly refer to OT, operational technology parsers. There's not a lot of those out there, and they can be a little tricky, and they will come back, and what will happen is and they'll get some false positives because the parser was built wrong, and so it's not getting the right data. But realize that a parser is gonna pull these specific fields out. If these fields make sense and are readable, it's probably that data. If you get back a bunch of hex or nothing, that might be an indication that this protocol may not be 100% accurate. That's something you need to remember when you're going to try to be that expert saying, hey, these queries belong to this protocol. And so you might, as you go and do some of the logic we're going to do down the road, be more specific and only use things that come back very clearly parsed. But anyway, what I'm getting at is I now know I've got SQL queries. We've got a dest IP and a source IP. The source is the machine making the query. We don't know that that is a SQL box. We can't guarantee. You can have SQL boxes query other SQL boxes. But we do know that if you receive a SQL query and you handle it like we've got here, this would be an indication that this box right here is a SQL box. We've just done some logic to determine that this is SQL. Much like Nmap, it's going to query the things, get back responses. If a machine responds back and it handles SQL, that's a pretty good indication it's SQL. Well, what about, let's look at some of those other logs. HTTP. If a machine is answering on HTTP, let's go look at it. HTTP. If you are responding and all these things make sense and they're parsing them out, then this is probably an accurate HTTP log, and you can say that this machine is a web server. Cool. All right, so how does that fit machine learning? Well, one, we need to bring these into statistical categories, and we need to automate this process. Someone can't just go around and we get an IP. Let's say we get an IP. We don't have the time to go out there and manually look at every log source and see if it's the destination IP for different things. That's a lot of work, a lot of time, and if I want to know an inventory and I want a nice clean dashboard, that's going to be a little tricky. So one of the things I've done, and I'm going to simplify this, and I'm not going to do every one of these for you. I'm just going to show you the general principle. I can do something like this. Stats count by dest IP. And when I do that, I've now listed all of my sources, all of my all of my blah, 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 I can't speak, all of my web servers. I might extend this to a larger time frame, and then I might do something like this. Earliest something like this. Because maybe I want to keep track of when was the first time I saw it. Maybe I want to open up a large window, or maybe, and I'm not going to go into how to do it, I'll let you try to, maybe I'll do another video on this another time, but you could set there as you can, got to get my words out here. You might want to update a lookup file every day with data. And you're going to say each day, I'm going to keep the old stuff and add in the new and update this this last seen field. And so the earliest time becomes the latest time. Hoping that's making sense. If not, I'll come back to it. Let's cover this really quick. We'll leave the time. We won't really talk about the time for a minute. We're just going to go output lookup, and this will be we're going to call this DNS. Nope, this is HTTP computers.csv. If I write that, I now have a lookup that I can refer to. And one of the things I want to do then is, okay, so I've got this every day. I need to make this update because and then the problem you have is you can run a query, you can save this and run every day and look at your most recent, like 1 day's worth of logs and update this CSV. And every day I'll have a list of all my web servers. You're gonna have to be a little creative because maybe some of your systems don't respond every day. Sometimes it's a rarely used website in the sense that it only gets traffic every 1 or 2 days. One day it could be a web server, the next day it couldn't. And so maybe you want your CSV to be a little longer, and that means you could either open up your window bigger, or you can use an append equals true, and you might do something on the lines of combining first scene. Each day you put in a date, and you make sure that date is there so that maybe you keep the stuff for 7 days and you just state when was the last time it was seen. And when it crosses over 7 days, you purge it. This is not the, I'm not focusing on that right now. I just want you to be thinking a lot of the work is involved in getting your data set correct. But once you've done that, you can use this. And so I've built a little KV. I'm going to actually, for now, let's just take them all, and I'm just going to put them all in here. It's going to take a minute. I've got my HTTP computers. Now I've got all my web servers. I identified 502 web servers on my system. Cool. If you want to keep it simple, just query a big window. This all time is not a good idea. Maybe you query the last 7 days and you dump that in. If that works for you, go ahead and do that. And so anyway, that's another way. The point is, I've got this. Now I can make another query, duplicate tab, and I can go grab my IP logs, stream IP. And if I look at my stream IP, that's going to be a listing of all my machines talking. And so let's go grab stream IP and make sure this works. Now I have IPs. Let's say we're just going to use the destination IP, or we want to use the source IP. But for this case, we're going to use the destination IP. We need to get some IPs back that we're going to go and feed into our model. And so maybe we made the rule that we're just going to look at just the destination IPs. So I want to go grab head, let's grab head 1 million, 100,000, sure. And then I'm going to do a lookup, and I'm going to grab this little guy here. I'm going to put that in, and dest IP as dest IP. Output count. Table dest IP count. Would help if I put the CSV here. These matched. Basically, it was telling me these machines are not DNS servers. Sorry, I keep saying DNS. These machines are not HTTP servers. These machines are. If they have a match, they're HTTP. If they don't, they're not. One of the things I like to do in my query is I just tend to put this little field in here, and I'll add one more. Eval is HTTP equals 0 or 1. 1 being true, 0 being false. In this situation, I'm going to take the append equals true off. Go ahead and just output that. I've added another field, so instead of putting out this count, I can do this HTTP. Why? This saves me some time because I'm going to do is HTTP, and now I can do is HTTP. And now I've identified, I have given myself a statistical number that I can use that says, is this machine HTTP? Instead of trying to supply desk ports. And desk ports are, well, desk ports are technically numbers, but I've got now a value that it can work with. So I know it's HTTP. If it's got HTTP, it's a web server. But what if it's a web server? What about other types? So let's do that again. Let's go back to MySQL, and we'll now do the exact same thing, but instead we'll use MySQL, and instead of being HTTP computers and is SQL, we'll go is SQL and HTTP computers, HTTP oops, SQL computers. Now I have a new lookup, and it populates real quickly my SQL servers. And now I come back to my original query where I was doing this lookup, and now I'll do a new lookup. I'll pretty much just copy it because why not? It's going to be done over and over and over again. SQL computers, and now is SQL, and I'll add that to my list. Eventually I'll get a field back. Oh, it didn't fit my data set. But the point is, if it matched, then I get a 1. And easily enough, I can fill null here. Fill null. If it's a 1, it's true. If it didn't match. Well, I can really fill that in, get my statistics correct. Fill null, and we'll go value. So if we make sure we write this right, fill null 0, and I'll just do is stars. Oh, it's got to be what? Oh, does not work that way. Okay. That's too bad. I could just leave it blank. Oops. If you leave it blank, it'll just grab anything that's null and put a 0 in there. By the way, so now I got zeros. Oh, wow, look at that. That's why we're not getting any values back. We wrote that wrong. And now we write this. Let's see, there's my SQL servers, and there's my HTTP. Now, one of the things we could really do to speed this up is we could go stats, count by dest IP. I don't notice they were repetitive. I don't need them repeated. I just need the uniques. So boom, now I have a much smaller list. This dest IP we definitely need to throw out. So we probably want to do dest IP equals star. This is all part of that process of getting your data massaged and get correctly. I hope that's interesting. So dest IP like this is actually considered a star. That sucks. So let's go. Just horrible query. Don't do this if you don't have to. But I want to get rid of that little blank. This is the process that is involved in massaging, getting your data normalized that you can do put machine learning into it. All right, so what I've got now is IPs and HTTP and is SQL. Now, to be fair, when we're looking at this categorical information, the only information, remember, you want to get your stuff to numbers. When we categorize, does destination IP have any bearing whatsoever on your category? No, it doesn't. It doesn't fit in the model. So I can leave this as a string. It's okay to be represented as a string because it's not part of the model itself. What makes it is, hey, are you a web server? Are you a SQL server? And you start to identify those systems based off of uh, your destination IP, I mean, based off of these values. And then when you just say what they are, then it matters. Hey, this IP fits in this category, but the IP itself is not associated with the model. Remember that. So anything that's going to help determine your model, you really need to get into numerical format. And this is a really easy way of doing it. I've now created a list of IPs. I'm starting to categorize them. But right now, there's still no expert advice here. I haven't built anything. This is just so I have a test set of data that I can work with. And I could go through all 1,466 of these logs when I'm all done with making this and go through and say, all right, based off these things, this is this type of server, this type of server, this type of server. But I found a much easier method, and I've actually incorporated that in to our little Splunk instance here. And we'll come back to that. But first off, let's go back to, will this be supervised or an unsupervised model? I'm hoping you're seeing that I'm going to lend my expertise into this model. And so I'm already telling you kind of what I'm going to do, but let's read it. Supervised is a machine learning approach that's defined by the use of labeled data sets. I am basically, if you come back here, what I was saying I wanted to do was I wanted to call this SQL. I wanted to call this web. If you have a combination of the two, it could be a SQL with a web server backend. Basically, as I look at these parameters, I provide categories. So right now, I'm hoping you're seeing, I'm starting to call this, I have created labels. These data sets are designed or trained to supervise algorithms into classifying data or predicting outcomes accurately. Using labeled inputs and outputs, the model can measure its accuracy and learn over time. Primarily used for the following tasks: classification or regression. Classification: assign test data into specific categories: apples, oranges, fruits, birds, mammals, whatever you want to call. You're going to categorize them. Sounds, I should go over the rest of these models, but doesn't that sound exactly what I'm doing? I'm trying to categorize this data, classify it. All right, well, that would be there. Regression: understand the relationship between independent and dependent variables. If I go look at this data, if I made one of these independent, the other one's dependent, sorry, one of these dependent, one of these, is there any form of really, do web servers have much in relationship to SQL servers? Other than the fact that typically if people are following best practice, you separate them, there's probably not much regression there. These variables are not directly related to each other. Um, so regression doesn't make a ton of sense. What about unsupervised models? Unsupervised learning uses machine learning algorithms to analyze and cluster unlabeled data sets. That would mean we don't label anything. We just grab that data set and we try to make it analyze and cluster the data together. These algorithms discover hidden patterns in data without the need for human intervention. So when I started to add these zeros and ones into the data, it became supervised. If I had just looked at stream IP and just looked at that log source and said, find all the similarities, and then categorize those similarities, that would have been unsupervised. So anyway, I'm hoping you're seeing here, I've already kind of given that answer, but let's go look at the places it's primarily used for. Clustering: grouping data together based on similarities or differences. That is not, there is classification and there's clustering. Classification, I'm giving labels to it. Clustering, I'm just doing similarities. What are those similarities? That's kind of up to the model. It will try to find what similarities are there. If you've seen data come back and you just say, well, you'll hear this all the time, k-means. It's just going to it's going to lump a whole bunch of fields together and say, when all these fields are together, they seem to be similar. When all these fields are together, they seem to be similar. That's clustering, but it does not give it a name. It's a group. It's just a grouping. Association: find relationships between variables in each data set. Dimensionality reduction: this is technically not a model of itself. It's actually meant to help feed other models. And so it's basically removing noise. Autoencoders, you'll hear that often. That's a dimensionality reduction algorithm. Its principle is every time you add a field, you add another dimension to your data. And you can try to run a pre-model to reduce down the dimensions. And so that's the principle behind a dimensionality reduction. And so really you're looking at, am I trying to make groups and associations, or am I trying to make classification, and in this case, find relationships between dependent and independent variables. The last model, I've written it here, is a different beast. It's supervised, it's outlier detection. And it can be both. You'll find models for both sides. With supervised detection, you must specify each row as an outlier or not an outlier. The Splunk stats command simplifies this process by using previous data and categorizing the data as non-abnormal, or you can leverage Splunk lookups. We covered that a lot in the previous video of this playlist. If you go back to my previous video, you'll see me using stats and lookups to do anomaly detection, outlier detection as a supervised model. And you can do unsupervised. It doesn't require training for each set of row of data. And when you have 1 or 2 dimension data, you can plot the data and visually identify. And so it basically puts plots, and you're looking for pieces of data on that plot line that don't fit the plot line. But the more dimensions you add, the unsupervised anomaly is close to a hopeless task due to the curse of dimensionality. This is straight from IBM. IBM is one of the kings of AI, and they basically said anomaly detection with a lot of dimensionality is a relatively hopeless cause. That's not my words, that's IBM, which in the sense of anomaly detection means that every point eventually becomes an outlier. This means keep the number of variables being evaluated to a minimum or the model's accuracy will suffer. Basically, if you start adding too many fields of data and try to say, show me the outliers, you will reach a point where everything is an outlier and nothing is normal. And that isn't very useful. And so if you can reduce down the amount of dimensions you're looking for anomalies, untrained has unsupervised models have potential, but as soon as you start adding a lot of dimensions in there, your accuracy becomes very, very low, and it becomes difficult to make decisions off of it. So that's supervised and unsupervised. My personal preference as a general rule, stay supervised and let Splunk cover that. That is what my whole video segment previous to this was about, was using supervised detection. Splunk excels at it. Use it. That's my recommendation. But anyway, coming back to our model, all right, which one are we going to use? We're looking at this inventory. Are we looking for anomalies? No, we said we'd like to determine what kind of device is being observed. And so that would be a classification. That means we're going to be using supervised learning. We're going to be looking at classification. And then here's a little flow chart. I can come look in here and I can see what Splunk recommends you use. I'm trying to predict a field value. It could be numerical or categorical. In my case, I'm trying to predict a category such as domain controller, business system, SQL server, web server. That would be a category. And so thereby it lists a whole bunch of categories for me to use. Ignore this little piece here. This is just my image I had happened to be highlighted. If you come into the app later, this will go away, but it's just cached. It's annoying, but I just wasn't willing to unload all my cache to make this SVM not be highlighted. There's nothing special about SVM. But anyway, here are a bunch of classification algorithms that I can use. And so I might go look up a little bit about what I want to do and figure out which one I want to use, but I've now got it limited. I could use, these are right out of the box. These are what they recommend. All right, I could do some processing, pre-processing, etc. I'm already doing that, preparing my data. So we're good. I can skip that. I use Splunk to prepare my data. And so ultimately my decision for the inventory categorization use case story is going to be supervised classification. I'm going to look at network logs. In the example I've been mentioning here, we'll use stream from Splunk. You could use your firewall logs, you could use Zeek logs, I don't know, whatever logs you've got that emphasize network logs. I mean, even Windows logs, you can turn on their network logs. So whatever you choose to use, and that's what I've done with my model. All right, that was a lot of stuff in which I haven't done a whole lot besides set up my framework. But that's the important part of this entire thing. I need to set up a use case story, and I need to see what kind of data do I have? Can I find that data? And then with that data, will I be using a supervised or an unsupervised model? Find out the classification, which type I'm going to be using, and then come grab a model that makes sense and see if it works. And so that's what I've done. Now let's go make my training data. I'm going to use I chose to use a random forest classifier. And I don't want to get into the big nutty, all the details here. You can go look this up. If you just type in Python random forest classifier, you don't even have to do that. It'll come back. There's documentation from Python and what it means. But the basic concept is it's a decision tree. It's much like this, but it's a little different. It's slightly different than a decision tree classifier. But the concept is it creates forest being the entire set of all of your data, and it creates uh, trees, and trees are decision trees. I don't get why they use that, but the concept is it's making decision gates. Think about if I want to go to the beach, the question would be, is today a good day to go to the beach? Well, I need to make some decisions on that. Basically, you could say, look at the weather. Is today beach weather? Some decisions. Is it warm? That would be a decision in there. Is it is it windy? Is it what's the beach like? What's the storm out there? There's a lot of things out there. Um, how do I feel? Do I have free time? Those are all decision trees, and when they come together, they ultimately form a category. And so that's what random forest classifier is. It's going to take all your data and start making decision trees off of them. So going back to my data here, this could be very simple. If it's HTTP, it's a web server. If it's SQL, it's a SQL server. Now it gets a little more complicated, but this is the model. If it's HTTP and a SQL, it might be a LAMP server, meaning Linux, Apache, MySQL. Anyway, so it could be a combination of servers. And so that's building all of those decision trees out. And we're going to help train that model by helping it understand some decision trees. We're going to build some decision trees for it. And the easiest way to do that is we come back here. I've got my data. I'm going to let this go away. I'm going to come back here to Splunk. I'm going to go settings, search reportings and alerts. And I built, so you don't have, if you want this app, you can take it. The concept is I'm building my own data. Eventually this will load. I'm going to use make results because I could go through all that data and decide build the logic. Or what I did here is I built make results. So for example, mine's a little more complicated here. I grabbed some fields. I said, are you DNS? Are you file share? Are you web server? Are you OT? Are you printer? Are you RDP admin? Are you SMTP? Are you SQL? Are you a scanner? And all of these were derived with using kind of the basic principle I use. I can figure out that data from stuff I've got. And so then I'm creating 50 logs that have a domain controller of 1 and everything else was 0. If that's the case, it's a domain controller. Then I'm going to come up with another use case. It could be a domain controller and DNS. In a Windows environment, often, almost always, the DNS server is a domain controller and vice versa. It's not mutually exclusive, but you can have domain controllers that are not DNS, domain controllers that are DNS. And so I accounted for them. They are domain controllers. Then I come down here and this is like, see DNS, not a domain controller, but is DNS. And it is category DNS. And so I'm just basically writing out my rules. I'm just going to continue to make results, add a whole bunch of logs in there and set the rules. Coming down here, I have a business system, right? Sysadmin and print. It's a printer. It's also an RDP admin system. And so thereby, if it meets those two, it's a sysadmin and print server. Sysadmin and print server can also be the situation where file share. Let's see, this one, file share. It had file shares. It's a file share. Often Windows boxes are file shares thanks to SMB. It's an RDP box and it's a print server. And so it's got all three, and I'm going to categorize that as system admin and print. Here I'm going to categorize this as system admin and print, but it doesn't have to have the file share. And here I'm going to go call this just a system admin box because that's all it's got. It doesn't have print server or file share. And so you start building out all of your concepts here. Here is my failback to. It wasn't a domain controller, it wasn't DNS, it wasn't file share, it wasn't HTTP, it wasn't OT, it wasn't a printer, it wasn't RDP admin, it wasn't SMTP, it wasn't SQL, it wasn't scanner. But I'm still going to categorize it, and my category will be unknown. And ultimately, I may have to come back and retrain the model as I start to find more data points that help reduce down this unknown field. But right now I want to categorize unknown. And because I'm categorizing unknown, this helps break that principle that people say you can't have a 100% accurate model. Well, depends on how you frame that. No, I can't actually identify every piece of network equipment. But if it doesn't meet my rules, I will categorize it as unknown. And so thereby I can successfully not categorize all my data, if that makes sense. I successfully categorized it, and there is a portion of it not categorized. And that's how an admin, that's how an analyst is going to look at these things. They're going to look at it. They're going to go do these real quick. Think of Nmap. Nmap scans the systems, and sometimes it just doesn't know. You're going to have to do a little bit more digging, a little more uh, stuff. You may have to go to the machine itself and find out what it is because it's not giving away enough information. And so I made a catch called unknown. There's nothing wrong with that. And if you do that, you can have 100% categorization. So I just want to make that clear for when we come down later, we're going to have 100%. And it's because of this category here. So anyway, I've done that. I've sysadmin print server, OT, web. Yeah, okay. So that is my general model. And so then I'm going to output this into inventory training set.csv. This CSV is already attached, so you don't have to create it yourself, but I just wanted you to know it was there. You don't have to run this, but this will help you build your training set. I actually have that built right here, and I can run it if I want to, and we'll just output the stuff. It doesn't take very long to run. Boom. Now I have 750 results, and basically it's going to come back and it's going to say, boom, 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 boom. Based off these rules, what am I? We can see it has a bunch of different categories. There's my unknown category. And then what I'm going to do is I'm going to come over here and I'm going to force it into my model. But there was one last class I built, category that I built, that I didn't want to try to have to manually make a results for. That would have been annoying. And that was the concept of, basically I'll write it out. Hey, it was a domain, if you're a domain controller, a DNS server, web server, OT device, RDP admin, SMTP, SQL, or a scanner, we're going to count all of those up. Remember, 1 is true, 0 is false. So if you're not one of these, you're not going to add to the score. And basically, I wanted a count of the business systems. And basically, what I came down here was, is the business system. This was to create me a place where, business systems were, it's multi-systems. I want to say on everything is domain controller with DNS and RDP access. Is DNS with domain controller with SMTP. And so I lumped them all together here. Just some ways. I just wanted to show the fact that I could add things in there. And then basically what I'm doing is but actually the sad part is I didn't ever end up incorporating into my model. And we can go back and we can do that if we want to. And so this line here is probably something I should have removed. It doesn't actually fit because I didn't end up writing them over here. But in order to make this truly work and identify business systems, I'm going to need a rule set to handle that. Anyway, and so that's what I did. But basically what I'm doing is I'm fitting a random classifier in, and I'm going to come back here and I'm going to pass in. This is the command to use a random forest classifier. Basically, what I do is I use the command fit. I call out random forest categorizer classifier, and I'm trying on the category field. Remember the category? We've made it all here, category, sysadmin, sysadmin, sysadmin print, unknown, file share database. And so it's going to say, I'm going to figure out the category, and it's going to be based on, look at what the fields are for domain, DNS, scanner, is business system, is DNS, web, blah, blah, blah. And if I do all that, it's going to come back and show me that, and it's going to fit it into this test inventory classifier. I did put this on here. This says, hey, how many gates, how many categories do you want? By default, I think it's 100, but that's been a recent upgrade. Sometimes it's only 10. So if you're not getting all your categories, you want to play around and change that. I don't actually have that issue, so I can leave it alone. Mine's set to run on 100 by default. It can handle up to 100 categories. Anyway, so it's going to make this model, and this is actually redundant. It doesn't really need to be there because all of my categories are going to match my guess. Why? Because I'm fitting the categories. Um, so I'm going to remove this where clause out. Basically what it's doing is saying whatever you tell me this is, I'm going to use that as my rules. What does that really mean? Let's just show it. It's going to run that lookup file, and it's going to fit this categories, and basically it's going to say, hey, I was a category, what's my guess? You're going to find that they're one-to-one. They're a one-to-one relationship. Why? Because it's a fit model. It used your logic and said, okay, if these rules are the case, that's what I'm going to predict. If these rules are the case, then I'm going to predict this. And now it's going to put a whole bunch of percentages and weights to all these fields that go on behind the scenes. But ultimately, these are always going to equal each other. But just for some weird reason, where category does not equal guess, I want to know, is there any case where the two didn't match? And it should come back empty. And it does. And that's because the guess field is what it predicted based off this model. And the reason it's predicting that is because you fed in the results. So there's really no reason to do this. I just wanted to point out that we're going to use this query another time, this piece, to test my model, and I am going to need that. All right, I've built my model. I hope this makes sense. We'll go over this again. I built a data set, and I basically created a whole bunch of make results, set my rule. I could have gone to these queries I was doing here, wherever that was. Yeah, I lost my sequel. But when I was writing, I got rid of it. That whole where I was writing off the bots 3 and then gone through and look up and check, 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 check. But that's a lot of work. I started doing that and I realized I really don't want to do this. Here was this model was 750 times. That's a lot of work. This will do really the exact same thing and guarantee I did it right. Um, so that's why I chose this. Plus, now I can use that bots v3 as a test case. If I'd used it as my training set, I really couldn't use it unless I use a subset of it. I really couldn't use it as my training set. And they'll often say what you want to do is a 30-70 rule. And so you'll take 30% of your rules, 30% of your training, your data, and use that to make the rule, and 70% to test against as training. I just used I didn't do that. I said, give me the 100%, use it all. Um, and I'm going to make my own training set that I completely control. And then I'm going to use that on another set of data. And the beauty is there's a bots v1, there's a bots v2, a bots v3. So you can do all of this and test against different data sets without even using your own network, trying to find network data. So that's why I like the bot set. Anyway, coming back to this. So we're going to come in here, and I've now created a new set of data. I have a training set test. And that was a set of data I went through and I created off of the bots data. And basically, when I did that, I now have my own model, and I'm going to do, it actually came back with a few other things. So I made some massaging here, such as, it's not really that important, but what happened was I found my data didn't quite come back right. Sometimes when you use lookups, they'll join more than once, and so I had multi-value fields. I needed to take care of that. So knock that out. I there one of the fields I there was no clean way on domain controller type. The field was saying GC global cluster, DC domain controller, forest. It was calling out the domain controller types. That was what was coming back in my data. So I needed to fix it. And so what I basically did is said, hey, if you don't have a type, no GC, no DC on there, put NA, and then I come down here and basically now I'm turning it back to zeros and ones. If it's NA, it's not a domain controller. Anything else became a one. It was a way of normalizing my data because remember, everything has to be integers. And so I did the same thing here. My RDP admin was coming back as a multi-value. For some reason, I didn't want to spend my time figuring it out. The data had multi-values. It was both 1 and 1, but that wasn't work. You can't, 1 and 1 as a multi-value is not a number. You need it to be a single value, not multi-value. And so I just basically, here was a simple way of fixing that as the data goes in, RDP admin, if it was 0, meaning it's not RDP, leave it as 0. Otherwise, what equals 1, make it 1. That made the ones multi-value go away. I could have done an MV expand, an MV dedupe, could have done this, but this was just a much easier, cleaner command. And so basically, again, coming in here, and this, again, I was lazy, and that's where you find this business system piece. Come back in. I was lazy, and I didn't want to be the expert here to figure out this model. I didn't want to. It was way too much work. And so basically, I created a little query here to have an expert mark the data using this logic. If the domain controller is 1, it's a domain controller. And remember, cases immediately drops out. If it's a scanner, then it's a scanner. If business system is greater than 1, the system is a multifunction server. If it's DNS is 1, then it becomes DNS. Is HTTP 1, web. So anyway, this is just basically the logic. This really handles, this is being my expert opinion, writing down what these categories were. Because I want to test what does the expert think the system should be, and then we're going to let this predict what the category is. And I don't have to do this if I believe my system is accurate. If I already believe that my model has a good fit, I don't need to put this in here. But because I don't want to have to go manually test every piece of data and say, yes, this is this category, no, it's not this category, etc. I wrote this little logic here in my Splunk, and this becomes that subject matter expert determining what a system is. And then we're going to let the model say, well, it's going to predict and how close did it match what this says. And so if we do that, we're going to come back here, we're going to table these fields, and we're going to just hit apply test inventory classifier. Where'd that name come from? Fit as app test inventory classifier. This app : just so you're aware, is a shortcut to say give the app that this runs in permissions to run it. So anybody in this app can now use my model. If I just took the app out, this would be created, but the model would be private to my account. And so I wanted to make it available to everyone. So in the app, so I wrote app : but when you call it, you don't use that app. You just use the test inventory classifier. And so if we do this, I'm going to remove these fields, and we're going to let this thing run. And it's going to come back. Here's the category derived by this logic, and this predicted category is what the model predicted. Now, category is not part of the model. It's not using this field to derive this. Don't think I'm cheating by saying, well, go just read this field and make it. No, it's reading these fields here and determining what it thinks it is. And let's see if it matches. Concept here, and you can read that in the model, the category field is derived from these fields. Category is not one of them. We're deriving the category. Hope that makes sense. And so the fact that I don't have to put this category field in here, if I removed eval category, this model would still fire. The difference is I wouldn't be able to tell whether or not it matches how accurately it matches. So we can sort, oh, it matched the DNS, the database is matched, unknown seems to be matching. So how well did the model work? That's what this little bottom piece was. Rename predicted category as guess. This is a nasty thing to write, so I renamed it. Eval correctly guessed. Here, this is we'll use a stats command. And basically what I did is where if guess equals category, if this equals that, it's correct. If it didn't, it didn't. I can show you all the queries, but I also can take you right back to the dashboard, and I'll come back and do both. So if we come back to our little dashboard here, we were able to, so we're going to go now, talk through the steps. Hopefully this is going to make sense again. I'm constantly jumping back and forth, but I'm hoping that as I do this, I'm reiterating these points that you need to cover while you're doing it. For this case, we're able to generate test data in Splunk. We made the test data using this make results command. Added the statistical fields required to determine the inventory categories, and these were them. And we can see that training data categories. These are the categories that we created. And we're basically resolution. These are resolved, these are unknown. And these fields are, you can see them, DNS, database. And so we can see how many fields we have that we're using in our test data, broken out, things like that. And now use the random forest classifier on the test data to create the model. We then grab sample network data from a live system. So we built the model, used sample data from a live network, and went to see how well it fits. We applied the model to sample data and tested predicted inventory categories versus the actual categories. And we see here that we have 99.89% correct, and the incorrect was 0.1%. And then we show values that didn't match. System admin was the category that was written in the sample. It says, hey, I'm system admin, and the model guessed system admin and print. First thing I actually am leaving this in here, I can make my model 100% match. That's not my point. I wanted to show you some caveats to messing up. Sysadmin, even if I hadn't had this and print, the fact that sysadmin and sysadmin are spelled differently, they're not going to match. So make sure you don't make those little mistakes. I did, and your categories don't match. Here, this was being a lot more verbose. I got lazy, and in my logic, I said, hey, if you're a sysadmin, basically the way this works, where sysadmin is RDP admin, you're one, but I didn't count for anything else. Whereas in my training model, I took into effect that you could be a system admin RDP, system admin print server, system admin and file share, and covered those. And so my model doesn't even have those in it. And that means they didn't match. Cool. That's easy enough to fix. And honestly, I'm happy with it. Knowing what I actually know, the fact that I identified it as a system admin box, go away. The fact that it caught it as a system admin box, I'm actually going to call that a success. So these fields here, they're all sysadmin and print. So this model, even though it says it was 99.89% accurate, it's actually 100% accurate. The reason, again, I'm going to go, but what you can't, if you make your model 100% accurate, thereby you lose some of your flexibility and the model actually is wrong. You'll hear that. That's the logic that people throw out models. Yes, but I created a category called unknown. And that is where those fields, I don't have a rule set, I don't have a case. That's that flexibility. It didn't fit these rules, then it goes into unknown. And so, yes, it's 100%, but it's not, but it's no different than any other analyst. It's just like Nmap. Nmap will do its best, and if it doesn't know what it'll say it's unknown. And so I do have 100% categorization, but there is some places I can't match all those. And so if I wanted to refine this model, I would be looking at trying to get unknowns determined, when and where it makes sense. Anyway, here's another way of showing it. My model was 99.89% accurate. All right, so let me show you. So this model works. That's it. That is the model in a nutshell. Now let me show you this last step of revise Splunk test data to improve model until accuracy or identification was at an acceptable level. What I found was my training models had to be, when I wrote this did not just get written and it just worked. We can do something very simple like, I'm going to add uh, domain controller, and I'm going to put in here RDP admin. If I put this in here, I'm now going to say that a domain controller has to have this, this, and this. Okay? And it's going to have an RDP admin. And I didn't add that extra category. And so I lost my domain controllers just standing by themselves. Domain controllers standing by themselves, it's got to be a domain controller with RDP admin. I just fat fingered it. We're just going to use that as the use case. I did this a lot when I was making my model. It's going to come back. It's going to write my model. And we're going to find domain controllers that are DC and RDP admin. Cool. All right, so let's go apply the model. This is going to look like it's just fine. My categories they'll all come back. There'll be no non-missing categories. But now I'm going to apply this model, and I'm going to actually take this logic here and put it here right after the test so I can actually see which ones don't match. And immediately I can see some issues is DNS1 here. Okay, we need to, come on. Let's see, let's go with domain controller. Actually identified that right, what happened? Oh, because of the logic here. Okay, let's take this out. So here, we're going to change this. Sorry, we'll use a different approach. Search is DC equals 1. Let's just find out what it came back with. This happened to be correct only because my logic stole it there. But this here will predict what? Huh. Did I not run my query? I thought I did. Okay. Give me a pause for a second here. Is DC 1? And actually, it seems to be being okay is RDP, but RDP admin. I wonder if, interesting, okay. Well, anyway, it still caught it. You just got to be careful if you start messing with these numbers. If you get some logic fault flaws, you're going to get some not matching. And that's really all I was trying to show. It was still clean enough that it caught it as a domain controller based off the logic I put in there. But you just need to be careful that when you make these rules that you don't put a false rule. You need to make your logic sound. Otherwise, you're going to have to go through every log and do it. You don't want to find, you know what? I don't want to declare a domain controller and find, like for example, that is DC is 0. That would be bad logic. And so just make sure that as you're playing around with these, that you don't, as you build your data set, that you identify things wrong. Typically, when the model doesn't work and the model, when you put it against your training, if they don't match, it's because your training set, that very first set, this stuff, the rules are wrong. And go back and go look at them and go fix the rule set. You might need to add a few more rules in there. You might need to tweak some of the rules, whatever the case may be, but that's what makes it happen. Anyway, so that's other places. That is my machine learning model on doing categorization. I'm hoping that was made sense. The next category we're going to go move through a little faster, and we're going to actually do outlier detections, and we will use some machine learning models on those. Anyway, well, so let's move to that next model. All right, we're going to see how well this goes. I have not actually done this model. I'm just going to work on it right on the fly, and we'll see how this works. Live demos are always fun. But anyway, we're going to make a new story here. This time we're going to say, I want to detect anomalous connections, anomalous activity, et cetera, et cetera. And so the concept would be, I would need to go through our little piece here. And my use case is we're going to look at network connections, and we're going to look for abnormal network connections. So would that be supervised or unsupervised? Well, my first gut when I thought about this was unsupervised, but the way I'm going to look at it is I'm going to use some models. I already know where I'm going with it. And those models are going to look at historical data, and anything that's not in that historical data would be considered anomalous, or something that occurs really infrequently would be closer to that realm of anomalous. And the stuff that occurs frequently would not be anomalous. And so I actually is supervised. We're not going to do an unsupervised anomaly detection. And we'll do a classification as basically, we're going to do outlier detection, and we're going to use supervised detection. I'm going to show you doing it really, really quickly with Splunk, and then I'm going to show you using the model. So what's our data set? Well, we're first going to come down here. We're going to do outlier detection. We're going to probably we can use this anomaly detection command. I'll use maybe some of these here, and I'll use a density function command. I'm going to use all three of those. And what's my data that I want to use? We're going to look at network logs. We're going to go back to the bots3 data set. So let's go there and see what we got. Index equals bots v3, and I'm going to go source type equals, let's go type equals source types. I actually already know the type I'm going to use, so I'm not going to make you find it. Source type equals stream IP. If I hit head 100 on that, we'll take this back all time so I can grab some data from it. And we can see here that we got some fields. We got a protocol, a stack here. Is this the ones we want to use? I was hoping for a service. Maybe I need to go to TCP. Doesn't look like I got a service here. Okay, so let's go Splunk TCP instead. TCP is going to give me a service if I'm not mistaken. No. All right, well then we're going to look for HTTP. Star. Show me where a field that has HTTP in it. App. Okay, so app equals star. And what's our source type? It is stream TCP. Okay, so I just missed it. TCP. We're going to go end stats count by app. So here are all my apps. And so what we can do is we can go grab, we're just going to go do this, let's say head 100. And now we have all of the known normal apps running on in this data. Wow, we probably shouldn't run in verbose mode. Anyway, so we got 125 services. So if I hit fast mode, let's run that in fast. And basically right now, what I've done, the reason we're going to say that these are approved normal services. Cool. Now what I want to do, I could do this stats count, just doing simple statistics in Splunk. These are very common. SSL is very, very common. And Google Trusted Store, that right there is Anomaly. Just as simple as that, I could use that to detect anomalous services, things that pop up very infrequently. And so I'd write some sort of query, maybe I look at it each day, and I basically say, hey, if it's less than, if the occurrence is less than 2, I could do something like this. I could go output lookup, and we're going to call it known services.csv. And then I could come in here and I could go, clearly since I used all time, I'm not going to find anything abnormal, but I'm going to come in here and I'm going to go head 1000, look up known services.csv. Did I write that right? Wow, brain's already forgetting what I wrote. Let's make sure that lookup exists. Is that what I called it? Yep, okay. And so we're going to go make a lookup, app equals app, app, output, count as match. Sure, we can do that. Now when I run that, probably ought to put a table out. Table, source IP, dest IP, app, and match. Okay, and clearly app needs to exist. App equals star, app does not equal something like that. If I do that, we can now find any services that don't match. And so maybe you'll go here, where is null match. I'm not going to have any because the data was built off of this. But if I ran this every day going forward, I now have built myself an outlier detection model. It's trained data. I said everything in the past was legit, and anything that wasn't is not legit. And that is as simple stats as you can get. You can do stats of the lookup, or you can just use stats right like that. We can do some other things though. Let's go, and I'm just going to go grab the last values, anomaly detection on what fields? We're going to go on app. I run that command. Now we're going to use, oh, I need to put a value down here. So let's go table source IP. The values are there. You just don't want to have to, they're all buried here, probable cause, probable frequency. So we're going to go source IP, dest IP, and let's just go grab the first head 10,000. It's going to tell me the anomalous apps. Would help if I actually had the field app in there so I could run anomaly detection against it. So what we've got is app New Relic. It rarely appears. Crux, Everest, Yahoo. These are my rare apps. Just as simple as doing that. I'm kind of curious why I don't have source and dest written there. Let's try this. Okay. And we're going to say source IP equals star. I want to make sure I actually get stuff that comes back. Okay. Now when I write anomaly detection, on app. I've got it. We're going to break this down after we've done everything on app. We're trying to make this as simple as possible. You'll see that we can just as easily add source and destination in there and use that method. But anyway, we can see these are the weird apps rarely occurring. There's your alerts. That's your outliers. Done. Bing, bang, no complicated model. All right. Well, you know what? Life's just not fun without a full model. We really need a model because models are super sexy, and that's what just spurs on that concept of AI. So we're going to build a model. So let's jump over here. I've already shown you anomaly detection. I've shown you I didn't use stream stats. I just flat out used stats, but I could have done some mean and medians and stuff like that. Didn't need to. We're going to use density function. All right. So what we'll do is we've got these here. I'm going to come back with, instead of doing head 10,000, we can actually do a few things. One of the things I could really save myself some time on if I want this to run fast. I already put that little lookup in there, didn't I? So if I go input lookup known services.csv, what do I got? There we go. Those are my known services. I'd go through here, and if any of them were not good, I would remove them. I'm going to say they're all fine for the sake of this. We want to be able to move along. We don't want to spend too much time. And we're going to say this, all of these apps are perfectly normal. So now what we do is we go fit density function. And we're going to call this, that's decision tree, density function. Density function. And we're basically going to use this count field. By app. Should work. Now I've created a density function. Here's these occurrences. And boom, I got a model. We're going to call this into app um, service outlier. There. I've now made me a model using this data. And these are my models. I fit this in. Boom. This will make a model. When it's all set and done, I got myself a model I can call on. It doesn't like all my data points. It would like a little bigger data points. I'm okay with that. I don't care. I'm going to come over here and I'm going to do something like, we're going to say add this. So we're going to go make results. I'm going to make up my own data set. Eval app equals add this. Table app time. Now I got a data set, really simple. And now we're going to go apply data model. I don't need to say data model. Go grab the name of the data model, service outlier. Put it in there, run the query. Is this normal? It's going to tell me, oh, okay. And so we can do stats count by app. Now I got to count. So I need to switch that around. Sorry. So why did you not like that? Okay, we're gonna do another eval. And I'm gonna call this foo. Run that. Okay. We need to change that up slightly. All right, what we need to do, I'm going to cheat. This is something I've used in Phantom. Index equals bots v3, source type equals stream TCP, head 2. Head 1, actually no, I could do that, but that's not what I want to do. We're going to do back to the original make results. Make results. Now we go append. Love it. Gotta love coming up with stuff right on the fly. Make results eval foo equals app equals foo. Close that. Now if I have that right, I should have 2. No. I should have 2. Stats count by app. Now I can do apply. Service outlier. We can see that foo drops out. It doesn't even fit in the boundary range. That to me is a dead giveaway that it doesn't, it's not there. So we can do something like this. Make fill null is outlier NA is outlier. If I did that, then I could go back and grab all my NA fields. There. Nothing special about it. I have gone a complicated method, but I have made a model and I'm applying the model. Oops. We'll just leave that alone. We'll just put NA there. And so you can do something like that. Just very, very simple. This is now using a service outlier, using that little using the little density function app to make yourself outliers. And so I can just grab anything that's a NA field, and those are my outliers. And you could do some more stuff and get some mathematical equations out of that. Again, I have, if we wanted to, we can improve this and start doing density function based off of source, IP, dest IP, and service, and we could fit that in the model. But I am just going to show you this, that I can also just as easily do bots v3 source type equals stream TCP stats count by source IP, dest IP, and app. Do something like this. I can see the abnormal occurrences. Again, I could build a baseline of what's normal and put it as a lookup. And then I could match that lookup against these. I could just flat out use based off of how often it occurs, call those anomalous. Um, and if you think about it, that's all this is doing here is it's just basically taking those percentages and doing the exact same thing. But I want you to notice, look at the search speed. This is significantly faster. I can put it in a really cool, sexy model. And then with those models, I could go draw some really cool pictures. But in reality, what are you trying to do? You're trying to detect anomalous activity, anomalous behavior. You can just as easily use the stats command. But I wanted to show that we could do the exact same thing over on the other side. And so the big thing is now we just need to turn these things. When you do this, these have to be turned into um, numerical values so they can go into a model. It becomes a little bigger pain as you start adding fields in there and to make those models fit. So I'm not going to go there because I don't see the value of it. The fact is, I've already started just by doing this. I'm starting to break my own rule. What does it say here about unsupervised? For very high dimensional data, unsupervised data is close to a hopeless task. And in the best world, you just want to stay away from it and just use stats. That's my take. If you want to use a supervised detection, it is supervised because there is some gaps here. You are assuming that the traffic you are using is good. Otherwise, someone's got to go through and say, yeah, that's expected, that's not expected. And as this data set gets big, like this isn't a very large data set, 5,154 values. I don't know a lot of analysts who can go through each one of these and say, yep, that's normal, that's not, that's normal, that's not. So in some cases, I tell you, just start baselining your network, and you almost just have to assume that what occurred in the past is normal. It's going to be difficult. I mean, and then you just keep tailoring your results as they go on, and that's just the way. And just be looking for rare occurrences or anything outside the norm. But that's basically what I wanted to show here. So let's break that down. I can then basically I can use any of these. I prefer the anomaly detection is actually really quite easy. Again, let's go here. If I go, that's the one I would do if I had to. Anomaly detection. But again, why source IP? Why do this when I can just as easily run a stats command? It's faster. But if you really like these percentages, you can go ahead and get the so this one here is anomalous, and the reason it's anomalous is because I'm guessing this machine talked to this machine a bunch, but this app that it used, this Debian update, didn't do very often, and all of a sudden it's doing that, and that's the abnormality. And so there could be some little bit of value here in the fact that you could see the cause, the probable cause, it breaks the field out, that's the most anomalous. It isn't so much source and dest, it's this Debian update piece. Anyway, those are your models, really simple for doing outlier detection. I hope they help, and I hope they keep moving you along. Hope these videos were useful. If you liked it, give me a like or a subscribe to my channel. I'd love your feedback down below if you have any questions. I hope you keep coming back.